Dear students, what we discuss in this session is type 2 error probabilities. As we have discussed earlier, hypothesis tests do not always yield correct decisions. Two types of errors are possible. Type 1 rejects H0. H0 is true. Reject H0, H0 is true. Type 2 accept H0, H0 is false. Or do not reject H0, reject H0, H0 is false. H0 is false. And as we have discussed, the probability of type 1 error is alpha, and this alpha is known as level of significance. Probability of type 1 error is known as alpha. Alpha is known as the level of significance or significance level. Probability of type 2 error is known as beta. Probability of type 2 error is known as beta. And 1 minus beta, that is probability of not committing a type 2 error, is known as the power 1 minus beta. Probability means accepting a false hypothesis. And beta is the power, beta is the probability of not accepting a false hypothesis. Now in this session, we consider how to calculate beta, that is the probability of type 2 error, that is accept H0, H0 is false. And in the next session, we will consider what is known as power of the test. Now for computing type 2 error probabilities, we must know three things. One is sample size. Computation of type 2 error probabilities depends on 1. Sample size, 2. Significance level, that is alpha, and 3. The true value of parameter. So calculation of type 2 error probabilities depends on the sample size, significance level alpha, true value of the parameter. Now to demonstrate how to calculate type 2 error probabilities, consider the earlier example. H0 mu was equal to 26 kilometer per liter. Suppose that this is the mileage of a car. Mu is 26, example which we have considered. H1, mu is less than 26 kilometer per liter. H0, 26, H1 less than 26. Assume that alpha is 5%, n is equal to 30. N is equal to 30. And sample size is 30, significance level is 50. Also assuming that the true value of the parameter is 25.8. True value of the parameter is 24.8 and also 25. 25.8 and 25. Now, we assume that the mileage is normally distributed with a standard deviation is equal to 1.4 liters. Mileage is normally distributed with the standard deviation 1.4 liters. Sorry, 1.4 liters per kilometer, km. Remember this, type 2 error probabilities can be calculated if and only if sample size is given, level of significance is given, true value of the parameter is known. So we assume that it is 25, other values will also be considered. Standard deviation, population standard deviation is assumed to be 1.4 kilometer per liter. Now, Z is x bar minus mu 0 pi sigma by root n is equal to x bar minus 26 by 1.4 divided by root 30. And this is a left tail test. So minus Z alpha by 2 is minus Z 0.05 is equal to 1.645 as we have discussed earlier. And the rejection region is, as we know, the rejection region is minus 1.645. This is 5%. And the value. If applying in the sample, if the value of Z is less than minus 1.645, we reject H0. Otherwise we accept. So this is the rejection region. This is the acceptance region for H0, given all this information. Now, computation of type 2 error probabilities is easy if a decision criteria is expressed in terms of x bar rather than Z. As I told you earlier, the decision to accept or reject the hypothesis can be taken either in terms of x bar or in terms of Z. X bar is the estimator and its sampling distribution is directly used for decision taking. Z is the test statistics derived from x bar. We can use both for accepting or rejecting the hypothesis. Now, as it is easy to derive type 2 error probabilities using x bar rather than Z, we reformulate our problem in terms of what is known as x bar rather than Z. So the first step is to find the sample mean, which is 1.645. We have to first find out the sample mean, which is 1.645 standard deviations below mu hypothesized under the null hypothesis, mu 0. That is, we have to find out x bar, sample mean x bar, which is 1.645 standard deviations below H0. Let us see what it is, what we are doing here. In terms of x bar, this is x bar. The hypothesized value is 26. And 95% of x bar lie between 26 plus or minus if it is a one-tailed test, 26 minus 1.645 standard deviation of x bar. If it is a two-tailed test, 26 plus or minus 1.96. 26 plus or minus 1.96 standard deviation of x bar. Now using this, we have x bar is equal to, as you can see, x bar is equal to 26 minus 1.645, 1.4 by root of 30. The value is equal to 26 minus 1.645 into, this is 0.26 is equal to 25.6. 25.6. Now, in terms of x bar, the decision criteria is reject H0 if the value of x bar is less than 25.6. If the value of x bar is less than 25.6, because only 5% of x bar will be less than 25.6. So this is the critical region. Reject H0. This is accept H0. So remember this point, 25.6. If x bar obtained from the sample is less than 25.6, reject H0. If x bar is greater than 25.6, x bar greater than 25.6 from the sample, do not reject H0. Here the decision is taken not in terms of Z, the decision is taken in terms of x bar. Okay, now we first consider the case 25.8. Suppose that the true mean is 25.8. Mean is 25.8. So, mean of x bar is equal to mu is equal to 25.8, and sigma of x bar is equal to 0.26 that we have already calculated. X bar is normally distributed. So, the distribution here is like this. This is 25.8. And what is the decision criteria? The decision criteria is sigma of x bar is 0.26. So, Z can be calculated like this. 25.8, sigma of x bar is assumed to be sigma of x bar is 25.x bar. That is the we assume that it is 25.8. Now sigma of x bar is 0.26. Now x bar is normally distributed, and if it is 25.8, then 25.6 is the critical value. Here reject H0, accept or do not reject H0. 25.6, 26, 25.6, 25.8. if 25.8 is the mean value, we reject H0 if the value of x bar from the sample is less than 25.6. And the Z score is, Z can be calculated like this. Z is equal to 25.6 minus 25.8 by 0.26 is equal to minus 0.77. And in terms of Z, this value is 0. This is minus 0.77. And the probability of Z on the shaded area is 1 minus 0.2206 is equal to 0.7794. So, as per this decision criteria, reject H0 if value of x bar is less than 25.6. Accept it is greater than 25.6. So, this is the rejection region, this is the acceptance region. So, the probability that the value of x bar is greater than 25.6 is 0.7749. So, type 2 error occurs if we do not reject H0 if x bar is greater than 25.6. Greater than 25.6. And the probability of this happening is equal to the percentage of all samples which is greater than 25.6 and the probability of making such an error is 0.7794 probability of making such an error. So, beta is equal to 0.7794. Beta, the probability of type 2 error is 0.7794. So, there is a 78% probability that we fail to reject H0 when the true mean is 25.8. We fail to reject H0, mu is equal to 26 when the true mean is 25.8. This can be systematically shown like this. Now, 25.6. And 26. This is alpha 0.05. Now, and this is 25.8. As you can see, this is 25.6 and this is beta. Beta is equal to 0.7794. 7794. And as you can see here, if you reduce the value of alpha to 0.01 like that, what happens? Beta increases. Of alpha is, this is alpha in the odd case. If alpha is reduced, beta increases and vice versa. That means for a given sample size, as probability of type 1 error decreases, probability of type 2 error increases and vice versa. And we can calculate other values by assuming that the true mileage is 225, the true mileage is any other value. So remember this, we can calculate type 1 and type 2 error probabilities by specifying the values of the two parameter like this. This is a left tail test. For a right tail test, we will give the value of mu greater than this. And for a two tail test, we will specify values below and above 26, and we derive the corresponding probabilities of type 2 errors. And from this, we will derive what is known as the power curve. That is our next topic of discussion.